Shahin, thank you very much for agreeing to come to the event. It's always a pleasure to see you and to catch up with you in this field, because you've been a leader in this area for many years, and your insights are always very helpful. So we're very grateful for your time. The event today, as you know, it's going to center on different aspects of regenerative medicine, and hopefully we'll address some of the challenges that are plaguing the field, some of which are biological and some of which are more structural. And I wonder if you have any general thoughts about how should we go about addressing first the biological challenges. What are the key questions that that you think we need to address to move the field forward? And then, in your opinion, what are the structural barriers for cell-based therapies to really start making a difference on the life of patients?
So I think the cell therapy currently is getting a lot of momentum, and to bring it to fruition, we need to focus on several areas. First is safety. The foremost is safety. The second is efficacy. And if cell therapy wants to succeed, we have to make sure that the organs that are want to repair or regenerate have a long-lasting benefit from the cell therapy. And the whole idea that we can transplant stem cells to repair heart or to repair brain or cure diabetes or Parkinson, I think is very simplistic. We need to understand how the stem cell, in a mechanistic basis, they acquire signal to differentiate to different tissues, and the whole idea about whether we should just transplant stem cell or their progeny is a big topic that needs to be studied at multiple levels. So I think that one area that any institution that wants to succeed in regenerative medicine has to focus on. Unravel the biology of stem cell differentiation, stem cell survival, and most importantly, how stem cells do not acquire signals that become malignant. And the second aspect of it would be how to deliver these cells, whether it's stem cell or their progeny, that can cause long-lasting organ regeneration. Then in that situation, we need to acquire expertise of biomedical engineers, tissue engineering. That's very important for if we want to repair a major damaged area of the heart. Just transplantation of stem cell is not going to work. We need to deliver these in a scaffold so can enable the cell engraft. And an area that is very important, and that's my expertise, is that no matter where with the transplant stem cell, the progeny in a scaffold, blood supply is very important. So any regeneration process requires that these engrafted cells or tissues to have adequate blood supply. And in my thinking, the blood supply that is mediated by endothelial cells, these are the unit of the blood vessels, are very important and very timely, because we have found that the endothelial cell not only make new blood vessels, they also produce growth factors. They have executive functions that allow this organ regeneration to take place. And so far I have mentioned about understanding the mechanism how stem cells regenerate, differentiate. Second, how we can put the stem cell and their progeny together in 3 dimensions, and how we can put blood supply. And the last important thing, idea and concept, and one of the biggest hurdle of regenerative medicine, if we want to regenerate damaged organs, one of the biggest problems is that these organs are scarred, they're fibrotic. Scar tissue has formed. That's best example is a patient who has myocardial infarction. It has a big scar tissue. And scar tissue is non-functional, and more importantly, scar tissue prevent regeneration to take place. So any regenerative medicine approach has to find out how we can take care of the scar tissue. Many groups are planning to maybe inject cells within the scar tissue, but I don't think that's going to be successful. So we have to understand the biology of inflammation and how inflammation leads to scar, and try to reverse that either putting the proper cells, progeny of stem cell, or try to vascularize the scar tissue to allow regenerating take place.
You brought up the issue of bone marrow transplants as one success story in this field. And I wonder if there are any lessons that we could learn from that long history of success in bone marrow transplant that would inform the development of therapies for other organs. Have you reflected on that? What is it that these people did, or what advantages did they have so that they were successful when this first came up, and how can we apply the same advantages now in the new therapies we want to develop?
Therapies, absolutely. I mean, first of all, the reason the success with the